definition of factoring that I could come up with. I'm going to take you through lots of examples and show you how to factor them. I'm going to use the best math terminology I have, and I'm going to use lots of colors so it's interesting and you can follow along where the thinking is at. So right here, 7 and 21 are multiples of 3, or 7. Eight x to the power of 2y plus 12xy to the power of 2. 4. And I take it out a common factor of 4xy. Eight and 12 are multiples of 4. And there was an x common in both of them and a y common in both of them. And I took out a common factor of 5xy, and in the brackets it's x minus 3y. And then I have 2x to the power of 2 minus 6x plus 12. And then we have 36 x to the power of 3, y to the power of 2, minus 60 x to the power of 4, y to the power of 3. And then I took a common factor of 12x to the power of 3, y to the power of 2, out of 36 x to the power of 3, y to the power of 2, minus 60 x to the power of 4, y to the power of 3. In the brackets, what's left is 3 minus 5xy. If you were to expand this out, you would get the original expression. Now we're on to trinomials. What set of numbers add to this and multiply to this? So that's the rule of thumb when you're working with trinomials. It's how you can begin to learn, and eventually you'll see how parts of this fit together, how when you expand out, you'll get the original expression and what adds to this and what multiplies to this. I'm talking about this term adds to this and multiplies to this. So adds to -1, multiplies to -2. On to the next question. X to the power 2 minus 8xy plus 15y squared. And this would be our final answer. And m plus 4 is our answer. And this is our final answer as well. So what two numbers add to -2 and multiply to -8? So in order to get s to the power of 4, I need to do s to the power of 2 multiplied by s to the power of 2. I also need to find two numbers that add to -15 and multiply to 54. Now this is a complex trinomial. So here's your final answer. 2x multiplied by x is 2x squared. 2x multiplied by positive 3 is 6x. Plus 1x would be 7x. That's the middle term there. 1 multiplied by 3 results in the multiplication term there, positive 3. Another complex trinomial. And there's your final answer. 3x multiplied by x is 3x squared. 3x plus 4. It does result in positive 7, and multiplied together results in negative 20. Four x multiplied by x is 4x squared. 4x multiplied by negative 1 is negative 4x. Add negative 3x to that, it's negative 7. And then multiply negative 3 by negative 1 is positive 3. What numbers add to negative 13 and multiply to negative 5? And also a tricky trinomial. Two a multiplied by 3a is 6a squared. 2a multiplied by positive 1 is positive 2a minus 15a. That would be negative 13a and negative 5. And positive 1 multiplied together equal negative 5. So what numbers add to negative 29 and multiply to 100? And there's your final answer. Difference of squares is easy. Let's factor out to see what's happening. As you can see a pattern forming here. The first two terms here are the same, and then these two terms are the same, aside from the operational sign. Difference of squares is easier that way because you know what sort of numbers to expect. Any perfect squares, not perfect cubes, perfect squares. Yes. As you can see, I'm going to them a bit faster. You see how the first two terms are x to get x squared. The second two terms are 5. It's the perfect square, and then what's switched is the operational sign. There's one negative operational sign and one positive operational sign. And when you factor this out, you get the original expression. With the lightsaber tool. Same with this one. And that's the same original expression. That's our original expression. And we end up with the original expression. And we get the original expression. And we end with the original expression. Let's factor this out or expand. And we get the original expression. Okay, now we're ready for factoring by grouping. So I see 2x being a common factor between these two, and a common factor of 3 for those two. Okay, so what we want is for these two factors to be the same. Then we're going to put this factor down below, and we're going to take what's left over, and we're going to create a new factor with it. I see a common factor of A and a common factor of B. And as you can see here, both of these were the same, and we took what was left over and made a new one with it. A new factor with it. For this one, I don't see any common factors, so we're gonna have to rearrange. I see an x squared And you can see both of them were the same. And I just factored as it would be. So a common factor of 3a and a common factor of -5. And as you can see, both these factors are the same. I'm sorry. It's been done in red. So for this one, we had to rearrange. We ended up with common factor of x and -y. Well, doesn't really. So now it's sum and difference of cubes. I have a to the power 3 plus b to the power 3 equals a plus b bracket a squared minus ab plus b squared bracket. That is for sum. A to the power 3 plus b to the power 3. And here's the formula. You follow this formula when it is a to the power 3 plus b to the power 3. You notice the operational signs that I'm highlighting. Make sure you know where the correct operational sign goes. There's a positive, a negative, and then a positive. Now for difference, it's a to the power 3 minus b to the power of 3. And then I have the formula right here. Notice I'm highlighting the operational signs. This one's a bit different. It's a negative first, then a positive, and another positive. The middle term right here, you're just multiplying these two terms together and either putting it behind a negative operational sign or a positive operational sign. So these two terms are connected to this term right here. And then in front and behind the middle term, it's a to the power of 2 and b to the power of 2. So memorize, where do the operational signs lie within sum and difference of cube. It's something that we'll memorize, just like any other formula as well. And underneath here, I've done some perfect cubes. I was talking about perfect squares before. Perfect squares would be something like 2 to the power of 2 equals 4, 3 to the power of 2 equals 9, 4 to the power of 2 equals 16. Perfect squares, things like that. And right now I'm looking at perfect cubes. I have 1 to the power of 3, 2 to the power of 3, 3 to the power of 3, and so on and so forth. I doubt we'll go higher than 6, but I'm just writing them out so you know what to expect. Okay, I'm going to give you a moment to write down the formulas, and I want you to look them over a few times. It's follow the formula. Follow the formula. Okay, let's begin. So x to the power 3 plus 8 is actually x to the power 3 plus 2 to the power of 3. So underneath, yep, that's correct. And this one, you're just using the variables, so this is just the formula. And there you go. This was a difference of cubes. And this was sum of cubes. Moving on. So x to the power 3 minus 27 is actually x to the power of 3 minus 3 to the power of 3. So the answer is x minus 3, x to the power 2 plus 3x plus 9. Moving on. Yep, that's correct. Okay, and then we have x minus 5 in brackets, and then we have x squared plus 5x plus 25. And that's difference of cubes. And that's, I rewrote it so you guys can see what the answer is. Okay, now we're gonna look at our very last topic here. That's expanding. Okay, so we have FOIL, which is firsts, outsides, insides, and lasts. And I've numbered them here: first, outsides, insides, and lasts. F, O I L. We're gonna do some expanding. 3x times 2x is 6x. 3x plus 5 times 5y plus 15xy. 4y multiply 2x minus 8xy minus 20y squared. Sorry, it's 6x squared. Plus 7xy minus 20y squared. That's the correct answer. For this one, we're going to need a bit of bed math. I'm going to circle our answers. That's the correct answer there. Healing. Okay. That is the last question.